So we're going to take a deeper look into some things about syntactic ambiguity now. We've seen that context-free grammars predict multiple derivations for many word strings. And so because of that, they can capture many cases of ambiguity that arise in natural language. And these aren't just corner cases, oddballs that you have to carefully construct or hunt around for. These are ubiquitous in everyday language use. And I'll give you an example. So this is from a newspaper headline a number of years ago. Brennan objects to use of waterboarding in CIA confirmation hearing. And if you take a moment to think about it, you probably identify a pretty prominent ambiguity. What is the role of CIA confirmation hearing to the rest of the sentence? So here is the interpretation that is not the right interpretation. Brennan objects to use of waterboarding, and in CIA confirmation hearing is where the use of waterboarding would be. That is not the right interpretation. The right interpretation is Brennan objects to use of waterboarding in CIA confirmation hearing, where in CIA confirmation hearing is where the objection occurs. So it's not that what Brennan objects to is using waterboarding in CIA confirmation hearing. He probably doesn't support that, but it's not what he's objecting to. Rather, in the CIA confirmation hearing, he's objecting to the use. The objection occurs. And so we get these for free, effectively, once we specify the right context-free grammar analysis. But the context-free grammar analyses don't explain where the interpretation preferences come from. And so that's actually a really important part of understanding this. And the class survey that I gave you actually is a good example of these kinds of things. I gave you this sentence: a friend of Mary's husband wanted to visit and look over our garden last Tuesday. And I gave you a number of questions, and we'll go through the questions and the proportion of responses. So in each question corresponds to a syntactic difference. So the first one is, who wanted to visit and see our garden? And one possibility is the husband of one of Mary's friends. In this case, a friend of Mary's would be a phrase, and it's modifying husband, or someone who is friends with Mary's husband, where Mary's husband is a phrase, and it's the friend of that person. And in this case, it was unanimous that the latter was the preferred reading. The second question, who or what did this person want us to visit? It could be us, and this corresponds to an interpretation where visit is being used intransitively. It has no intended object, and it's inferred that the visiting is happening of us. The other possibility is that our garden in this sentence is not just specifying what the friend wants to look over, but rather what the goal of visiting is too, what the desired visited thing is. And this is a transitive use of visit. So visit has the object, our garden. So visit and look over is a phrase. Technically speaking, this is a little bit complicated syntactically, because look over is not just a verb, it's a multi-word expression, and in particular, over is the beginning of a prepositional phrase. But we can use the kind of slash passing notation that we had before to say that visit is being used intransitively, but its object does not appear in its normal position. Rather, it's extracted, and you can actually come up with an analysis that actually gives you that transitive use of visit. In this case, over 80% of people chose that interpretation. Third, how does last Tuesday at the end of the sentence relate to the rest of the sentence? And this is interesting. There are three options here. It could be when the person's desire arose. In this case, it goes with the verb phrase that has wanted in it. It could be the time that was preferred to visit and look over the garden, in which case the adverbial phrase would go inside the visit and look over our garden phrase. Or it could be just the desired time of looking at the garden, in which case it would go in this lowest verb phrase. And in this case, once again, almost 3/4 of people chose the second option here. Finally, we have the question, what is meant by look over our garden? And this is really interesting, because it turns out there's quite different syntax in these two cases. So one possibility is that it might mean that I'm on one side of the garden, and I look across the garden to the other side. This is literally, where am I looking? I'm looking over our garden. The other possibility is that the person wants to look the garden over. And this is actually really interesting, because in this case, look over is what's called a verb-particle combination. So look over combines to mean something that's a kind of looking, but not just everyday looking. It's inspect. And interestingly, in this case, over does not actually form a phrase with our garden, unlike in the first case. And you can see because I could actually reword it. I could change the word order, and I could move over after a garden. I could say look a garden over. So these are two very different meanings with correspondingly different syntax. In this case, almost everybody chose the latter interpretation, look it over. Okay, so we have these 4 examples. Now, think about this. So there are 20 trees available from these 4 ambiguities. There was a two-way, a 3-way, and a 2-way ambiguity. And it's 20, not 24, which you might otherwise expect, which I'll leave as an exercise why it's not 24. Nevertheless, fully 66% of respondents chose this analysis that I've illustrated here, which arises from the majority preference for each of the individual analyses. Of the people who did not choose this, 18 preferred an analysis that differs only in 1 ambiguity, and the other chose an analysis that differs in 2 ambiguities. So there's a theoretical challenge that is raised by this, which is the question of what determines the preferred analysis, and how do we as native speakers even get to the preferred analysis if all of these options are available at once. And I want to also frame this not just in the problem of ambiguity, but a similar kind of problem arises about prediction. So this is a big picture view of the way that incremental language understanding unfolds. At any particular moment in time, we've got recent preceding input, say from the preceding sentence that we're in, from the current sentence that we're in, and then we have information that's outside of that context. So we have more local context and then extra sentential information, previous language or maybe visual information in the environment. And then it turns out we're implicitly predicting. We know this because of things that we saw earlier on about how people differentially skip words that are more predictable, for example. So we have current input and we're making predictions about that. And our expectations about current input are always shaping how we analyze that current input. We saw that also, for example, in spoken language understanding. And there are many kinds of ways in which these expectations form. And they're guided by a number of different information sources. So for example, here's an illustration of how syntactic information guides expectation formation. If I give the beginning of a sentence, Jamie was clearly intimidated, and I just ask you now to think for a moment about what comes next. And you probably think of maybe many things, but probably the next word that you'll see is by, that you think of as by. And then the next thing that comes after that is what is the source of intimidation. And that's interesting because overall, the most common thing that would happen after the word intimidated is just not just going to be the word by, it's going to be who's getting intimidated. But because of the syntactic context that it's in the passive voice, we have this prediction for a by phrase, and in particular, the reason for the intimidation. So there's this rich interplay of syntax and semantics. The semantics of what it means to intimidate, and the syntax of the kind of structure that you're in before it. Here's another example. Teriaden. And in this case, I have the semantic knowledge of what the word, what it means to eat, but I also have the phonological knowledge that "an" can only occur before certain kinds of words, and then of course I have the syntactic knowledge that "an" initiates a noun phrase. And so, for example, in this case, apple, orange, and ice cream cone might be things that you might think of, whereas if I had Terriate then you might instead have thought of nectarine, banana, and sandwich. So here we have some syntax, but also really semantics and phonology interact. And then we have what we might think of as more situational knowledge. So the children went outside too. You're going to think play. If I say the squirrel stored some nuts in you think statue. No, you don't. You probably think tree, even though squirrels usually store their nuts in the ground, not in trees. But all of these are examples of how there's not only disambiguation of we're always determining the structures of what we're seeing, but very quickly we're predicting. And so a big picture view here is that we're actually deploying these rich multiple information sources to analyze, disambiguate, and predict. And that's all happening through grammar. And so how do we formalize this? And now we're going to go back to Anderson's view of rational analysis, and we're going to apply it to syntactic processing. Rational analysis says, here's what you do to build and iteratively improve theories of the mind. You specify precisely the goal of the cognitive system, formalize the model of the environment that you think the cognitive system is adapted to, make minimal assumptions regarding computational limitations, and derive predicted optimal behavior, compare predictions to those empirical data, and iterate as necessary. So let's do this. I'll specify precisely the goals of the cognitive system as efficiently analyzing, and analyzing means quote-unquote processing, the incoming linguistic input and identifying the intended meaning. Second, formalize the model of the environment. So this is going to be statistics of the linguistic environment and knowledge of interlocutors and their goals. In particular, this will lead to knowledge about what structures are likely, in what contexts, and what kinds of more surface level realizations are more likely given what structures. That will come from experience with the linguistic environment as a native speaker. Third, minimal computational assumptions. I'm going to assume that fast and near normative Bayesian inference is feasible for real-time language processing. That is, that a native speaker can, under ordinary circumstances, get something very close to or indistinguishable from, for our scientists' investigative purposes, the right posterior, the normative posterior that probability theory implies, on the structural interpretation of the input, given the input, taking into both into account the likelihood and the prior. And this is going to be important because optimal processing will involve using that accurate posterior. So we'll take predicted optimal behavior in any particular case on this basis, and we'll use controlled experimental case studies to investigate real-time human language understanding under this rubric. In cases where we succeed in making good predictions, then we'll say we've done well, we have a good theory. In cases where we fail, we'll see that we'll ask how do we revise 1 through 3 and see what we should get instead. And this is going to involve, because we just invoked Bayesian inference, we have to put probabilities on structures. And one really important insight is that actually some kind of structures are rarer than others. So for example, here's the same meaning, or something very similar to the same meaning, expressed in 2 different word orders. Across the path darted a squirrel, as opposed to a squirrel darted across the path. The first structure is a very unusual way. And so we might find it more surprising or unexpected, and if there were some ambiguity, we might disprefer it. The second structure is a canonical. The first structure is what's called locative inversion. The relative order of this locative phrase and this subject are inverted relative to their ordinary order. And that's a very unusual construction. The more frequent is the canonical ordering, where the subject is before the verb is followed by the locative prepositional phrase. And so if we want to be able to take those frequencies into account, we want a model that will probabilistically score parts of a tree. And one simple model for this is what's called the probabilistic or stochastic context-free grammar, PCFG or stochastic or SCFG. So we're going to pause now, and when we come back, we're going to look at the probabilistic context-free grammar and how to do inference with it.